right, so today we're going to talk about the law of cosines, and this is going to help us solve those last couple of cases we haven't talked about yet. So just to kind of recap what we've talked about so far this unit, you're going to use the law of sines on the angle-angle side and the angle side angle, and also the angle side side cases of given information. This last one being the ambiguous case, that one takes the most work out of all of them for sure. And today we're going to look at the other two solvable cases, side angle side and side side side. And instead of using the law of sines, which is that proportional equation, we're going to use the law of cosines. I don't think we have enough time today to go through the proof like we did with law of sines, so I'm just going to give you the formula. Now, depending on which case you have here, you're going to use like a different form of the formula. And what I mean by that is like we're sort of rearrange it a little bit. So even though I'm going to write down two equations here, know that they're really the same one, just manipulated. So let me just go ahead and just get right at it. If you've got a side case where I've given you like the three sides of the triangle, you need to find all three angles, right? And so you're going to use this formula to find the angle measures given the three sides. So let's just say that you want to start with angle A in a triangle ABC. Cosine of angle A is going to be equal to some expression that only has the sides, right? Because you don't know any angle measures, you only know the three sides. So here's the formula. B squared plus C squared minus A squared over 2BC. Now that'll give you cosine of A. Now this is if your sides are A, B, and C and you're trying to solve for angle A. But as you can imagine, not all of the triangles are going to be labeled like that, right? It might be triangle XYZ or PQM or whatever, right? So you can change this formula to match whatever kind of triangle you're trying to solve by realizing that these two sides right here are always going to be the two sides adjacent to the angle you're solving for. Okay? And then this side right here will be the one that's opposite of the angle you're trying to solve for. So this right here is going to be the angle opposite of A. And these two sides are going to be, oh wait, no, not angle. Wow. The side opposite of angle A. And these two will be the other two sides. Same thing down here. These are the other two sides. So I just want you to think about this more, generically than just this sort of form of the formula. We'll do an example so you can kind of see how that plays out. But a little tip here is that this kind of problem can become very hard very quickly, depending on which angle measure you solve for first. So to stay safe here, I'm going to give you a little tip here. In this situation, always find the largest angle first. Now, if I'm given three sides of a triangle, how do I know which angle is going to be the biggest one if I don't know any of the angles? Yeah, it's going to be the one that's opposite of the largest side. So like if you have, like let's say side A is 3, side B is 4, side 3 is 10. Well, that probably wouldn't even make a triangle, but you would solve for angle C first in that case, whichever one's the biggest. If you do that, you can avoid some weird things that can happen. If you don't find the largest angle first, you can fall into the trap of generating an angle side-side scenario where you don't really want one, and get like erroneous solutions, and you don't want to have to deal with any of that. So to avoid all of that, just make sure you find the biggest one first, and then you can avoid that. All right, so that's if you're given all three sides. If you're given two sides and the included angle, or the angle between the two sides, a side angle side scenario, instead of solving for one of the angles first. Right now, we can only use this version of the formula if we know all three sides, right? So we can't really use this one to find one of the angles here because we only know two of the sides. We know one of the angles. We're just trying to find that other side. So if we want to find like side A here, we could rearrange this, yeah? And we would have the three other pieces of information, the angle and the two other sides. So I'm going to rearrange this for you and say that a squared is equal to b squared plus c squared minus 2bc times cosine of angle A. It's very similar to the Pythagorean theorem. Yeah, in fact, that's kind of where it's rooted. Again, you know, if we went through the proof, you would see like why that, you know, why it looks like that. But anyway, so this will help you get that third side. Now, once you have the third side, it's sort of open season for what you want to do next. If you have three sides in one of the angle measures, you could fall back into law of sines after that. Or you could just use law of cosines again. So once you get, once you do the first law of cosines, you could do law of cosines again and again, or you could just use law of sines. Sometimes that's easier. And you guys have a lot of experience with law of sines already anyway. So these are your two equations. And really, it's the same equation. That's sort of the little secret here. It's just rearranged, depending on what you're trying to solve for. So we've got enough time for a couple of examples here. Do y'all have any questions so far?
I want to see the proof, but I know we don't have time.
It's a much longer one than the law of sines. Yeah. If you're all right, so let's say now I'm not going to use A, B, and C because I want to kind of get you away from being locked into these letters and just think more about like where the letter, where your variable should go anyway. So let's say we've got a triangle where side Q is 18, side R is 21, and side S is 27. And so this is going to be a side scenario. So we'll use that first version of the formula. So we've got Q, R, S, and it doesn't really matter how you orient this. When we're dealing with the law of sines, particularly the ambiguous case, it was pretty helpful to sort of arrange our diagram the same way every time so that it would be clear like which angle we're trying to get for. Here it doesn't really matter. I don't know that you get any benefit, mostly because we don't have to worry about the height here. 18, 21, and 27. Okay, so the three things we need to solve for are angles Q, R, and S. Just as a little reminder, we want to find the biggest angle first so we can avoid any erroneous solutions. So which angle should we get first then? Angle S. Okay, so let's go for angle S. So I'm going to I'm actually going to make this a little smaller to give myself a little bit more room to write here. And this is not going to be to scale at all. Just squeeze this in here. Okay, so angle S. So I'm going to set this up as cosine of angle S, and so let's see if we can fill out like the rest of the formula. So the first two, the b squared plus c squared, those are the two other sides, not the one opposite of the angle you're trying to find, right? So the two sides not opposite of S would be the 18 and the 27. No, I'm sorry, the 18 and the, that should not be 27, that should be 21. 18 and 21. So we've got 18 squared plus 21 squared minus 27 squared. Over 2 times the two sides that are not opposite of this angle you're trying to find. So that would be 18 and 21. So at this point, you're going to use your calculator, and then we'll get a fraction here, and then we'll take the inverse cosine of whatever that is, and that'll give us our angle measure. So let's see, 18 squared plus 21 squared minus 27 squared is 36. Yeah. So 36 over 2 times 18 times 21, 756. So to get S, we just need to inverse cosine that. And so we get about 87 degrees. So now we've got all three sides. We've got one angle measure. We have a couple of options here. We can either start doing law of sines again to get the other two angle measures. In fact, well, we really only need to do it once, because to get that third angle measure, we can subtract from 180. So to get that second angle measure, we can either do law of sines, or we could do law of cosines again. Now, usually I'll do law of sines as much as I can, just because it's easier for me to do the proportions. But let's do one more law of cosines, just so you kind of get the feel for how that formula all plays out. So what, at this point, it doesn't really matter which is the next angle you want to get. So what angle do you want to do next? R? Okay, so let's do R. So let's see if I can fit this on here. Cosine of R is, so help me with this formula here. Okay. So what was the first thing you said? Well, yeah, we don't want to use 21 yet, because 21 is opposite of R, right? So we want to start with 18 squared plus 27 squared. So those are the two like opposite angles, or not adjacent sides. Minus 21 squared all over 2 times, and it'll always just be like these first two things that we're multiplying. So those two numbers you'll write twice. And if you do this enough, you'll get used to that. So R will be the inverse cosine of this over this. So I got 612 over 972. Does that look about right? Okay, so that would be approximately how many degrees? 50? 51? 51 degrees. Okay, now we could do law of cosines or law of sines again to get that third angle, but there's no need to do all that, because if you have two angles in a triangle, you should know the third one, right? Because you can just subtract from 180. So that last angle measure Q will be 180 minus 87 minus 51, which would be, let's see, so that's 138, so 42. Does that sound right? 42 degrees. Any questions about the side, side, side case? All right, so the what? Oh. Just like with the law of sines, you're just plugging the numbers in the formula and solving for whatever the variable is. That's really what these are going to boil down to. Okay, so let's try the side angle side case. So let's say we've got angle Y is 62 degrees, side X is 9, and side Z is 12. So it looks like we've got an XYZ triangle here, where this is 62 degrees, side X is 9, side Z is 12, and side Y is unknown. So what are the three things that we need here?
X, Z, and Y.
Angle X, angle Z, and side Y. Okay, so in a side angle side case like this, you're going to use law of cosines, but you're going to use that other version of the formula where you've got the the a squared isolated. Now, obviously, we don't have an a here. So what we do have though is y. So we'll start with, let's maybe just rewrite the formula. Instead of using a, b, and c, let's see if you guys can get this formula down for x, y, and z. So for side y, we'll start off with y squared equals what? Help me write the rest of the formula.
It equals,
With no numbers, just like with x and y and z.
it'll be equal to
Right? Mm-hmm. Right. So you might have to sort of repurpose that formula with whatever variables you have at play here. So that might be a good idea to just sort of rewrite the formula every time so you make sure you're plugging things in correctly. And at this point, yeah, it's just a matter of plugging stuff in and we'll get our answer. Yeah. And as you can see, we're going to have to take the square root eventually. But let's fill everything in. So y squared equals 9 squared plus 12 squared minus 2. Let me push this up a little bit. Times 9 times 12 times the cosine of 62. So this is all something you would just throw in the calculator. Yeah? And our final answer is going to be whatever you get there, and you're going to take the square root of it, because this equation solved for y squared. So it'll be the square root of all of that. So what do we get for side y? Let's say to the near, like 1 decimal place. 1.1. Okay. So we've got side y. So now we're set up pretty good here because we've got all three sides in an angle. So to get the last angle, that will be the easiest part because we just need to subtract from 180. But to get the other angle, either x or z, we've got some options here. We can either use law of sines or law of cosines. Now, again, even though law of sines is probably easier, let's use law of cosines just to get a little bit more practice in there. So what angle do you want to get next? Yeah, we definitely want to go for z next because that's going to be the biggest one. Yeah. So let's get, so cosine of angle z would be, let's see if we can repurpose this formula. X squared plus y squared minus z squared. Yeah? Are y'all with me so far? So these are the two other sides, and this is the side that's opposite of the angle measure you're solving for. Divided by 2 times x times y. So let's plug everything in there. Get 9 squared plus 11.1 squared minus 12 squared all over 2. What was x? 9 times 11.1. So then z would be the inverse cosine of whatever this over this is. So I'm getting 60.21 on top. Is that okay? And then 2 times 9 times 1. I'm getting 199.8 on the bottom. So angle Z is approximately what? All right, so 72 degrees. Or did you say it's 72.5? So we'll say 73 degrees. All right, so it's about 73 degrees. Now we can get the last angle measure, which would be angle X. But luckily that angle X should be the easiest thing to get here. So angle X should be 180 minus 62 minus 73. And what'd you say it was? 45? Okay. 45 degree angle measure. So these were the three values I got. 45 degrees for X, 73 degrees for Y, 11.1 for side Y. Oh, I'm sorry, 73 degrees was angle Z, not Y.